Okay, so here, this is actually the next slide. So we left off with here. We left off here, I'm sorry. We left off here. Now we're moving on to here, right? So let's say we wanted to solve this inequality on top. I mean, I wrote the solution already. But let's say we want to solve that one, where this is less than 0. Well, it turns out there's no solutions here. There are no solutions to this inequality. Now, why is that? Well, one of the properties about absolute value, that's what I'm saying here, is that the absolute value is always non-negative. You know, whatever is inside, whatever you're taking the absolute value of, it's always going to be non-negative after you take the absolute value of it. That's just an immediate property from the definition. So in other words, if you want to know when this is true, well, from here, what we're going to have is this. You're going to have, again, you're looking for all x. So that is numbers you're looking for. You could plug into for x. So you're looking for numbers you could replace x by, where the absolute value of this is non-negative, but also negative. So it would be greater than or equal to 0 and less than 0. Well, that's impossible. You know, that doesn't make any sense. There's no number that's less than 0 and greater than or equal to 0. In this case, if you had this inequality, you would have no solutions. In other words, the solution set would be the empty set. Remember, the empty set is the set with nothing in it. Let me just write out the notation for that. I did show the notation before, but there's 2 different notations you can use. Okay, that's not good. Let me try that. Let me try that again. Let me see if I can try it again. Nope. Although I did show the notation before, but I feel better doing it. Okay. Something like that. Basically, I'm trying to draw curly braces with nothing in between them except comma. You could also do this. You have a 0, and then you put a slash through it like this. Remember, these are the notations you can use for the empty set. Although in my class, if you just wrote this, the solution set is empty, that's fine. Okay. So again, you can't have absolute value negative. So, all right. Okay, anyway, let's now keep going. So normally I would give a worksheet, but again, since we're in this virtual class, I'm not sure how well that would work. So what I figured it'd be good to do is to have you guys try some examples. So, of course, oh great, the solutions here, but anyway, I want everyone to try this out for a few minutes. So let me pause the recording. And maybe not. Yeah. Okay. Well, actually, no, let's do this one together. Sorry. The next one I'll have you guys try out. Let's do this one together. Okay. Okay. My mistake. All right. So this one we'll do together, okay? All right, so here we're going to solve this inequality, okay? We're going to solve this one. Okay, that's cool. So what do? We have this inequality. Again, it's really just a reminder. You always want to get x all alone. You know, it's just like an equation. You want to get x all alone. Everything else that's not involving x, you want out of there.
Wouldn't you have to add 12 to the other side, not subtract it? Because it's already.
Yeah, that's what I was just thinking.
Oh boy. All right, let me fix that. It's easy to fix. All right. Unless I can do this. Let me change the example. That's what it should have been. There we go. Okay, I hope that's better. Okay. All right. So yeah, we'll make it plus 12. So here, same idea, right? You want to now subtract 12 from each side. So that should have been addition. Sorry about that. We have 6 times x is less than -2, right? Again, there's no absolute value here, so you don't have to worry about another inequality. Then we have this. We divide by 6. And we get x is less than -2/6. I wrote that as -1/3. But if you left it as -2/6, that's fine. But we get our solution set would be this. Right? Remember, this funny looking, this figure 8 symbol is here, since it has a minus, it's minus infinity or negative infinity. And we're looking at everything less than -1/3. That's why we have this notation.
Don't you have to switch it from less than to greater than because of the division?
Only when you divide by a negative.
Oh, okay.
Okay, so since it's a 6, that's not negative, we don't have to. Good question, though. Okay, remember, you only switch it when you multiply or divide by a negative. But this is our solution set. We graphed it as well. I put an open circle up here again because we're not including -1/3. It's strict inequality. All right. Okay, so stop. Okay, I want you guys to try an example. Let me keep that. Any other questions? All right. So here we want to solve this inequality. All right, that's pretty good. Well, here's our solution. So again, what we want to do, right? It's just like the other example, right? What we want to do is we want x to be all alone, right? Okay, so we have -4. Well, let's get the 4 out of there by adding 4, right? Then on the left side, you have 5x. On the right side, you get 20. So we have 5x is less than or equal to 20. And again, what we're doing here, we're preserving the, how do I say it, the solution set. We're not adding any solutions or removing any. Okay? So now, as you can see, we're dividing by 5. Now, 5 is positive, okay? So we don't turn the inequality around. We leave it the way it is. And so by dividing by 5, we get x less than or equal to 4, as you can see. And so what we end up with is this here. And we know the solution set for this, right? It's all numbers less than or equal to 4. And that's what this is. Right? We have a closed circle because we're including 4. Okay? It's including 4. And notice the arrow is pointing to the left because x is less than or equal. And so we have also this minus infinity. Okay. All right, so that's an example. Are there any questions about this? As you saw it before, I can definitely make mistakes. I'm able to. I'm human also, just like you guys, just like everyone here. So, don't be afraid to ask. So. Okay. So if there's no mistakes, if there's no questions, let's move on. Here's another one that I want everyone to do as well. Okay, so again, let me just stop the recording and give you about 2 or 3 minutes. Okay. Okay, so again, we want to solve this inequality. Okay, that's cool. That should be fun. Is it recording? Beautiful, good. All right. So, again, we want to solve it now. Now, notice what I did here, okay, was I simplified the left side. I know this should be hidden over here, but that's okay for now. Simplifying is something you can do, just like with an equation. You can simplify either side first. I mean, the right side, the 4x plus 8, there's nothing really you can do there because 4 times x and 8, they're unlike terms, so you can't combine them. But on the left side, we have this, right? So basically all we can do now is just distribute, which is what I'm doing, okay? From here, 2x minus 1 we have, right? So again, we distribute, we have 2x plus 2 times 1 is 2, minus 3, we get this. All right, that's awesome. And now some more. Now that was fun. So let's have some more fun. Let's actually solve the inequality. So this is what we have on the left side, as you can see. So we want to solve this. So again, what do we do first, right? Well, so again, you don't have to proceed in this order exactly. What I did was I subtracted 8 from both sides. Okay. Mostly because you want to get x all alone somehow. Okay? So here's what I'm doing. I'm subtracting 8, I get minus 9. Notice next, I'm subtracting 2x from both sides. So here the 2x's is gone. And we get 4x minus 2x, which is 2x. Although looking at the bottom, you could probably see why I proceeded this way. Because when we divide, we don't have to turn the inequality around, right? After this, we have 2x less than negative 9. So we divide by 2 because we want x. But again, we don't turn the inequality around, okay? We don't do that because we're dividing by a positive. So we have x is less than negative 9 over 2. So here's our wonderful solution set. And this is a mistake because that should be an open circle. So this circle here should be open. But basically what we get is x is less than, right? That's what this is saying. So we have this set, as you can see. So this solution set here is right, but this circle should be open. And why should it be open? Because we're not including negative 9 over 2. Okay, any questions on that? Okay, let me give you another one to try. Yeah, first let me just fix that. Uh-oh. Okay, I thought it froze. Got scared. I thought it froze up, but let me just fix that real quickly. There we go. Good. Now I'm happy. I just fixed the mistake. So again, it's an open circle.